Yeah, welcome everyone to our office hour session. We are joined by Rasul, the lead dev at RLN. So I guess we can start with, I will open up the floor for anyone to raise their hand and ask any questions you may have right away. And thank you, Rasul, for joining us today. This is awesome of you.
Sure.
If you guys don't have a question, you can even share your feelings so far if you have dug into the circuits and so on. And Rasul, you could get started by sharing your screen, because I think most of the questions will be kind of around the circuits.
Yeah. Do you see it right now?
Yeah, I see it. It's perfect. Cool. It's perfect. So, fellas, anyone has any questions to get us started?
I have a few questions. Am I audible?
Yeah, go ahead.
Okay. The first one is like, as we know that this circuit is designed to mitigate the spam, but can't someone just populate or send the same message again and again? How do you counter that?
Yeah, they can send, like anyone can send the same message again and again, and they won't be slashed because the share will be the same every time. Yeah. So, and the thing is that these kind of attacks, they are prevented on network layer. So if peers see that like the same message is sent, they can just decline this message. So the attack is because it is like anonymous environment, and the real problem is that like when you send different messages, it's hard to say who is like sending these messages. Like when it's like different messages and it is like anonymous environments, and in this case RLN helps. But if it like if it is the same message, we can just easily prevent that on network layer.
Makes sense.
Yeah.
Another question I had is, as far as I understand, there is same message limit for all apps. So have you considered having a separate message limit for different apps?
Separate message ID, you mean, or
separate message limit? So consider that there is app A using this RLN circuit, and there is app B using the same. In case of the current circuit, both of these apps will have same message limit, right? Like you can.
Yeah. No, the different apps can use like different message limits easily. Actually, the thing is, maybe you noticed if different apps use like the same things, I mean like the same external amplifier, and user uses the same like identity commitment and like the stuff, like users can be easily slashed. But that was the reason why we used actually external nullifier. External nullifier, as you know, it is like hash of app ID and epoch. So that's why there is no like intersections between different apps. But different apps can use different message limits for different users. Sure, why not?
Okay, cool.
Yeah.
Okay, another question I have is, this is not related to the circuit, but that contract that you shared, in there is like withdraw is two-step process. First you need to do withdraw, and then there is a release. So my question is, like, when you do withdraw, at that time only the Merkle route is updated, right, for the nodes. So once you do withdraw, from that moment onwards, you cannot send a message, right?
Yeah. So can you see the contracts also?
Yeah. Can see.
Yeah, the thing is that we had a problem with withdrawing and slashing. The problem was that I don't know if you came up to this yourself.
Yeah, I understand.
The problem is that users can self-slash.
Yep.
For example, they can spam a lot of messages and then quickly like make first request to like withdraw. So that's the problem. That's why we like use some time lock. So first of all, we have like two different things. We have withdrawing and slashing. Slashing is I actually explained it like previous time. Slashing is when you withdrawing the stake to a different address, to address that not registered this identity commitment. And withdraw is when you withdraw money to the same account. And the thing is, with slashing, also there are like two different problems. One problem is basic problem because of it is like anonymous environment. You can easily use RLN protocol as tornado cash as a mixer. So you can use it like for money laundering. So it's the problem also. That's why we like came up with fees. So when you withdrawing the money to the same address, there is no fees because like you clearly not laundering any money. You're just using RLN. And if you are slashing, if you are, and by slashing, I mean that you're withdrawing the money to a different address. You can use it like a laundering for money laundering. That's why we take fees from slashing. So that's how we solved first problem. And actually, you also can ask where we send fees. It was also like actually a non-trivial problem. We decided to send fees. We don't have this in our contracts because it is like application level stuff, and like builders, users of RLN library can decide themselves. But we recommend. Is it like everything clear for now?
Yeah, makes sense.
But we recommend to implement separate contract. First of all, like what should we do with fees? We think that we thought that we should send the fees to Gitcoin, for example, or to sponsor like gas sponsor like pay for transactions of registration, for withdrawing, for slashing. Also, I think the best solution we came up with is burning the fees, right? But the problem is that we use ERC20, and for example, if it will be USDC token or USDT tether, the problem is with burning tether and USDC that all money will go to Circle, Circle or tether company. Yeah, that's the problem. And we decided to have like to recommend users, library users, developers of RLN apps, to implement separate contract that will have only one function, to swap ERC20 token to Ethereum and then burn it. And this call will be compensated. So you can like freely call this function. And fee receiver is basically this contract that will like receive ERC20 tokens, and at one moment some user can just call swap function, and that's it. So that's how we deal with fees. Is it like clear, or does it?
Yeah, that's clear.
And
my question was
you can ask.
Can you please scroll down?
What please?
Can you please scroll down?
Sure.
Yeah, okay. So in case of withdraw, there are 2 points. One is withdraw and one is release. My question is like, once you withdraw and in between the time period of release and withdraw for the freezing time, is it expected or is it intentional that user can send messages, or at the point of withdraw only you upgrade your Merkle route, so users cannot send?
When you call the withdraw function, function, it's like already is withdraw function. Why we have time lock? To just give some time for other like RLN users to slash this person. Because if like the user is spammer, then someone should be able to slash him. but if like a user created the withdraw request, it's clearly that like this user, this identity commitment, this rate commitment will be like removed from Merkle tree. So we are clearly like removing like the user
Yeah.
from Merkle tree. Yeah.
Cool. Makes sense. Okay.
Mhm.
One last question that I have. This is not related to any issue or anything. I just found this maybe weird. In case of current implementation, the cost of attack doesn't scale with the impact. Like even if I send one spam message or I send 100 spam message, the cost of attack remains minimal deposit only. So if I want to, let's say I come in there and in that second only I spam the network with 100 messages, all the amount that's going to be slashed is my minimal deposit. And even if I do this twice, then also it's minimal deposit. So have you considered somehow scaling the penalty with the impact?
But how you like gonna send more than one spam message? I think if
Uh,
you just
yeah, so
will have time to
cons-
do that, but you will, but as soon as possible you will be removed, right? Because of
yeah, but that happens on chain, right? And
yeah.
there will be some latency. Before that point, I can send as many messages as I want, right? And I will be penalized only the minimal
Yeah,
deposit.
but if the event is created, or also other thing, your internal nullifier is just repeated twice, right? If you
Yeah,
spam,
Mhm.
so nodes can just how can I say that? Nodes can just easily decline your messages on network layer also,
Mhm.
right?
Cool.
Does it make any sense? I think
Yeah, it makes sense. But thing is, like the time between nodes notice and raise it, between that time, someone can still spam with multiple messages. And my concern was that, like, that gives a window for someone to spam the network multiple times than just what he is being penalized for. Like he's going to be penalized for minimal deposit only, no matter what, how many messages he sent.
yeah, I understand. Yeah, as I said,
Yeah, I think we, as Tyler also said last time, this is an old problem, and it will be dealt with at the P2P layer, right, Rasul? So the peers will simply have mechanisms to deal with someone who's just sending the same
Mhm.
message over and over again.
yeah, sure.
Yeah. So I just wanted to make sure that the fellows understand where the sending the same message over and over again doesn't reveal the secret. So could you highlight Rasul line 35 in the RLN circuit? So I think we talked about this last time, or 34, yeah. So the Y doesn't change if you're sending the same message over and over again. But as soon as you send a different message, the Y becomes different, and you only need two. Sorry, you only need message limit +1 to reconstruct the secret and slash someone. Is that correct, Russell?
Yeah.
Okay. And I think let me. Could you, Russell, go over, because I think this is really cool and nifty, the way that you guys um uh the way you guys went around the blow up in the polynomial degree as the limit increases. So could you explain that again?
Sure. Yeah, I can explain that. So, as you guys maybe, I think you know that we have like polynomial interpolation, right? Shamir secret sharing scheme, and the thing is that we can recover the secret value if we like and interpolate actually any function by like endpoints, like how we can interpolate, we can recover the, how can I say it?
So for a degree 1 polynomial, you need 2 points only. You need
Yeah. For a degree like k polynomial, like in general case, for degree k polynomial, linear polynomial, you like need
k plus 1. Yeah.
K plus 1 points from this like polynomial. K plus 1 shares, you can also say.
Yeah.
So we think like if we need like higher message limit, then we need to have like higher degree polynomial also, right? To like have more shares to recover the secret.
This was in V1. This is what you guys thought in V1.
Yeah. But then like our teammate also like left. He's actually gonna join the, I think, came to talk about like growth 16, right, Ali?
Lev, yeah.
Yeah. Actually,
on Friday.
it was his idea to add this range thing to RLN. So we have this message ID. It's just a variable, just a counter, and it adds some like randomness, and we are able to use like first degree polynomial, and at the same time we have like higher message limits. So how should I like explain in more details that, or?
I think it's straightforward. So
it's straightforward, yeah, but I don't know even how to explain, because if someone have question, if someone don't understand, I think it's easier to explain it personally, to like directly to someone, because for me it's like already, because I know how it works, it's pretty clear. Yeah. But if you don't know this, it's maybe unclear. I understand. So if anyone has questions how this works, I can like fully explain you.
Do you guys understand how the degree of the polynomial doesn't blow up with different message limit? So if the message limit is 10, we don't need to create a polynomial that requires 11 points to reconstruct through interpolation. It's always the same linear polynomial. Do you guys understand that? It's line like 34, basically, why the same polynomial works regardless of the limit. Does it make sense? Okay, well, I hope it does. I think nobody's asking, so.
Yeah. Yeah, it's like, I think it's even probably in documentation or RFC. I think I explained it like in more details. I don't remember fully. Yeah.
And then like staying on the same line, 34, the reason why the same message can be spammed repeatedly without any like ability to slash is because you sending the same message doesn't reveal the secret. It doesn't leak. It's not revealing another point on the line that which you can use to reconstruct the line. But as we said, this is something that is dealt with in the P2P level, basically. I think we have, let me look at the chat if there's any more questions.
Yeah, and actually also like the one cool feature from this range thing, from this for this message ID thing, is that every message. So how to remove chat from screen?
I think, oh, you mean notifications? You can just click on it.
No. I opened the chat to answer the questions, and now I cannot like.
On the top corner, I believe.
No,
Upright
like,
or left.
I think Zoom is like lagging. Okay, no problem. The thing is, if we have like a scheme I described before, if we have like higher degree polynomial, like to have like higher message limit, we for each message user sent, it like the user will have same nullifier for each message, and just you can just, do you understand why? Same internal nullifier for each message the user sent, it will be like the same. So system can understand that this is like the messages from the same user. We just cannot ban him. We just cannot ban this user because because the user didn't exceed the limit, but there will be the same nullifier for each message. And in this system, we have because nullifier is a Poseidon of A1 coefficient, and A1 is depends on message ID. There are different nullifiers for different messages, so it's not pseudonymous system, it's fully anonymous system, and you only your anonymity is only broken in case of you exceed the limit, but till that moment it is fully anonymous. Does it make sense?
Yeah, that makes sense. Let's take a question from Akansha. So the question is about what kind of bugs or problems fellows should be looking at. I shared, guys, yesterday 3 testing well, I wouldn't call them framework, but just helpers to help you test the code base. So Rasul, what have you personally used to test out the circuit?
Circumtester tool.
Yeah, have you done any fuzzing, something like that?
For the circuit?
Yeah.
No. I think we had them proper testing and formal verification during our audit. Yeah, but in general, we didn't do fuzzing, just simple tests. You can actually find these tests also in the repo, so it's just super basic. And
I think
maybe we can call integrational tests. So I think, as I said, we have dApps built on RLN protocol. I think it's more than. I think there are not one dApp. I think VAC team uses RLN in Vacu protocol. Yeah, so there are a lot of use cases of RLN. So
yeah, makes sense. But speaking to testing specifically, I think what I saw from people, not in this fellowship only, but generally, is that they wanted a framework that can quickly run the test without worrying about the key generation and all that. So just generate dummy keys and do that in the background. So the only thing that you wanted to do is to make sure that the circuit, for example, or component is always outputting the right returning the right thing without.
I think circumtester tool is good for that.
Yeah, it's good. It's one of the ones that I shared yesterday. So
yeah. That's the one tool. And for other tools, someone asked any other tools that we are using. I'm actually not using any other tool. I'm using also Circom language server protocol. So it's recompiling and gives errors in VS Code. You can also set up this, and I'm just for tests I'm using circumtester, and that's it actually. Circumspect, I'm not using circumspect actually.
Okay, I'll ask you after the session, Rasul, to share the last one, and I'll add it to the list that I shared.
I can send it right now if you want.
Another question. Let's take a question from Chen. He's asking, can we arbitrarily change the external nullifier to construct a valid proof and not reveal the secret? So can you play around with, I guess, I think it's line 27. No. You scroll down, Rasul.
Yeah, sure. 1 second.
Yeah, line 33. I think this is what Chen is asking about. If you play around with the external nullifier so that you can basically send a different message without actually leaking a second shard.
First of all, it's really hard to play with external nullifier value to generate like good A1, because Poseidon is like not real function to brute force. But in general, even if we can brute force Poseidon, we cannot just simply use other external nullifier, because it is like public input, and all public inputs are constrained like of the circuit. So they are constrained, like, how can I say that? They are not constrained in the circuit, but they are checked like outside the circuit. Like it is checked that we used right external nullifier to generate a proof. Yeah.
Yeah, the public input is part of the circuit setup.
Yeah.
and
For
it's
example,
normal.
as we check that the root, the same thing you can tell, for example, you can say that we can simply make membership proofs for some other Merkle tree, right? We can make membership proof for some other Merkle tree, and it will be like good, like a real valid proof. But I mean, if we just check the proof, it will be valid. That's why we also need to check if the root as public input or output is correct. Also, is the same as the root of real Merkle tree in the RLN app.
Makes sense. So the previous question wasn't actually Akansha is saying it's not about tools, but about the type of bugs. And yeah, so in addition to under constraining, Rasul, are there any type of bugs that you have come across previously, something that fellows should be in the lookout for?
I don't remember, actually. It's hard to say. Hard to say any bugs that we have in circuits, because I don't remember, honestly. Yeah, for the contract, I remember that we had some bug in the contract. I can tell about this when I actually implemented the logic of like withdrawing and slashing, like withdrawing with time lock.
Yeah.
I had the thing that I didn't check that in slashing function, the receiver is like not the same as not the same address, like so actually
not the same address as the person being slashed.
No, I mean, if for example I created withdraw request and someone else can just take the same call data and use it for slashing, and there is no way for them to receive money, it still will be me who will receive like the stake, because like the recipient thing in withdraw circuit is for that. But the problem is it will be slashing, not withdrawing, so the fee will be taken. But I'm not spammer, so it's just repeat attack, if we can call it repeat attack. Yeah. So we prevented that already. Also, our teammate find out this bug. Yeah, but I don't remember. Like there are a lot of bugs.
Well,
like
yeah, it's the circuits.
Yeah,
just like any other software, the classical thing is there is a difference between the intent of Rasul and what the circuit actually does. So you can just find potentially vanilla bugs that the intent is not exactly, the circuit is correct, there is nothing wrong with it, but there is a difference in intent, or there is a mismatch between intent and actual implementation. So Okay, just for the interest of time, let's move to the next question from Igor. Igor is saying, can you explain or show how the root of the Merkle tree is being updated between nodes, and how if they are subscribing to the contract events? So
this is also like in general, it's also applicational layer level stuff, but we don't have like what do you exactly like mean by
Igor,
updating the root
are
of Merkle
you
tree?
Igor, which contract are you referring to? Are you referring to the
No,
example?
we don't use Merkle trees on the contract. Just how you can update Merkle tree is just like application level stuff. But in the contract, it is like we have ordering, right? With the help of smart contracts and with consensus of Ethereum, like EVM in general, we have ordering, and we outputting in for registration. We're outputting the index and all necessary parameters that we need to insert like leaves to a Merkle tree, right? So I'm not sure about this question actually.
Can I speak?
Yeah, sure. Go ahead.
Yeah. So my question is just like because there is like for example, right now I can use the smart contract in order to register within the network, but then how is like the root is being updated between the nodes? Do they listen to the blockchain, like, and out of the events emitted, like they reconstruct like the root?
Yeah. They listen to the blockchain.
And if there's like anything like out of the original circuit, like do I need like to post any kind of like proof, I guess, like to the network as well? No, or it's
why?
Nothing. No, you don't need it.
No, I don't think so. It's just like when you're registering yourself, like there is like event that emitted, and nodes are listening to these events and like implement like.
So I would only use like circuit locally in order to create like identity commitment, and then use it like to pass it to the contract.
I don't think that you need to use circuits to create identity commitment. To create identity commitment, you just need to generate random value, random secret value, and that's it. And for sending messages, you are using the circuit.
Okay. So then you would need the circuit in order to send the message.
Yeah, and to withdraw also. To withdraw / but to register in the system, you don't need any.
Okay, and then the route that you are using, like how do the node just like a general interest, yeah, like how the node like would be how the nodes would be keeping up to date like with the latest route.
So they are listening to the blockchain off-chain events, on-chain events, and they updating the route locally. Updating Merkle tree locally.
And then there is kind of like consensus here between them, so that everyone like is on the latest route or something. No?
It's not necessary actually. It's not even necessary because they can update Merkle tree however they want. If they like won't update it correctly, there is probability that they will receive spam messages. First of all, and second thing, if they like don't update Merkle tree properly, they won't be able to create. If they want to send messages, they won't be able to create right proofs, right? So I mean, other nodes will reject.
By update, you mean locally update, right, Rasul?
Yeah, locally update.
Thank you.
Makes sense. It's not necessary to have consensus even for that, because the process with updating Merkle tree is really simple. So we have like indexes of like identity commitments, and we simply update locally the Merkle tree, reconstruct the Merkle tree, like inserting, removing. And someone also is like asking what happens to a leaf if we like remove identity commitments. We just like put default value. Default value is like 0. We just put 0 value. So we are using, you can use any Merkle tree for that, but we're using, for example, in Vacu protocol, we're using sparse Merkle tree. So it's like big Merkle tree, and there are like default values, and we are, when we're inserting, we insert the value, and when we are removing some leaves, we are putting this default value right back. Yeah, it was kind of like that. Does it like make it clear? No.
Yeah, thank you.
The Rasul, I wanted to ask you, if the app decided to change some parameters like the rate limit, like the number of limit per user or something like that,
Yeah.
will
That's
the
question. I think you don't it is like you can in general update like rate limit or message limit, this kind of stuff, but then you need to fully reconstruct Merkle tree, so it's like non-trivial task, but you can do it actually. Like theoretically you can do it, but I don't think it's like easy to do it practically, because you fully need to update like all the, yeah.
It changes the circuit basically in the current implementation. If you change the message limit, you would totally have a different circuit that you have to.
No, message limit is it's private input. No, why?
Okay, no, but I mean,
Yeah.
For each dApp there is a message limit. Is the message limit right now per user or per dApp?
In general, it's I would say it's per user,
right?
Because yeah, it's private input. It's just hashed together, and like rate commitment is calculated. So it's like that. So you can actually easily, if you want to change message limit for users, you can just easily. It is like easy thing to like in general. I mean, but
yeah,
by doing it like on chain, it's really hard, because of like it will. If for example RLN membership set has like too many people, it won't be possible, at least in one transaction, to update all like message limits. And then also like each node will have to like update Merkle tree to reconstruct the Merkle tree with new rate commitments or something like that.
yeah. So an idea I had in mind is if you can decouple this parameter from the circuit itself. If there is an on-chain storage slot that you can use as input to the proof of the circuit, so that what you are proving is not that the message limit is X. You're proving that the message limit is this value on this storage leaf on the Ethereum blockchain, for example. And that way you decouple it from the circuit so that people can change it up and down without having to. But I don't know if that breaks something somewhere. Does that break the commitment that each user has to do? Maybe it does.
I don't think that it breaks the commitment.
Okay.
Mm-hmm.
Okay, it's just an idea, like just a side note.
Yeah. We also think on that, because like, for example, if I deposited like big stake, I want to like decrease my stake, and therefore I need to also update my rate limit. But I think it's possible. Yeah, I think it's possible, theoretically. Sure, but I don't know if you really want to do that, like, practically.
Yeah. It's something to think about. Maybe it's a hackathon idea, maybe for someone to decouple that, to create. Maybe it's not only just like the message limit, but other admin parameters. They can create a contract, an admin contract that updates these things, and then the circuit is actually proving the state of this admin contract. This is what the admin is imposing right now, etc., etc. So Vishal is going back to the question about the leaves. If I remove the 4th and 7th, will there be collision between default value hash? So I think it's asking if two users have been slashed and removed from the tree, the 4th and 7th will be the default value. Will there be a collision?
What do you mean by collision?
Well, I guess they're asking because the 4th and the 7th leaves will be the default value, but no one, obviously it's a 0 value, so I guess you can't prove, you can't create a commitment for the default value.
Yeah.
Because
sure.
it's the 0 address basically, right, Rasul?
Yeah. Sure.
Yeah.
If you can like brute force hash function to find the preimage for 0 hash, it's
yeah,
it'd be like cool, but you cannot do that.
Hopefully that answered the question, Vishal. Okay. Great question, guys. Any more questions, whether in the chat or you guys can raise your hand and speak up as well. Feel free. Or if you have comments about your, going through the contracts, how you're feeling, difficulties you might be finding, things like that. This is your chance to also speak to that. Okay, I guess if there are no more questions, we can wrap up here. Hello? Someone spoke? Can you raise your voice? I can barely hear you.
Me too.
I can barely hear you. It's very, very low.
Is it now audible?
Yeah, now it's better. Go ahead.
Okay, the actual my doubt was, suppose that there are 8 leaves in a node, 8 leaves in a binary tree, and we remove simultaneously 4th leaf of the binary tree and the 7th leaf of the binary tree. So when we remove the 4th leaf of the binary tree, we will put the hash of the default value by the contract. So the same hash of the binary value is put in the 7th node, but there will be collision between the same hash now because we are hashing the same default value.
Yeah, we just, as I understand, so you mean like collision or removal, right?
Yeah, because we are updating.
We just explained that it's not the collision, so it's just basically the default hash. You cannot create nothing wrong with having like the same default values
So the
as the like nodes in Merkle tree.
Okay. So suppose that two people have the same secret hash, and both of them place the messages. So we will get the 2 different points now. From that, he can construct the linear y is equal to mx plus c. Then he can get the hash secret value.
Maybe you can, Rasul, point to line 27, I believe it was, on the in the RLN circuit. I believe that's what, or line 20, yeah, 27. I think
Yeah,
this is
here.
So yeah. So my question was, suppose there are 8% and 2 of them have the same secret hash. So both of them in the each epoch with
No, they cannot have the same secret hash. How they can have the same secret
yeah.
hash?
So my question was that only. Suppose that in the 8 leaf, first we remove the 4th leaf. So we put the default hash of the value 0. So the tree has the 0th hash in the 4th index. And in the next round, we remove the 7th leaf, 7th leaf. So again, we have to put the hash of the default value, that is hash of the 0. So there is a collision between both of them.
No, if there is like zero, like zero value, like where hashes of leaves are stored, that's not a problem because you don't know a pre-image of zero value of Poseidon hash function, and you cannot brute force that. It's like hard cryptographical problem. You only can do like brute force and brute force of 2 to 128. So it's like hard to find the pre-image for zero value. So it's not a collision. Like having default values in the Merkle tree is like it's fine. So it's not a problem.
Okay.
Yeah.
So for a user to take advantage of a zero leaf or like a slash or any uninitialized leaf, Vishal, they would have to prove the knowledge of the pre-image that resulted in the zero address or which is the default value, something like zeros, a bunch of zeros, which is not possible. If Poseidon is safe as a hashing function, right? The hashing function is one way. Does that make sense, Vishal? Perfect. Any more questions before we wrap up? We could have maybe 5 more minutes.
I had another question.
Sure, go ahead, Vishal.
Can you tell me where we have proving the integrity between the Shamir's secret value and the hash value?
Difference between secret value and hash value?
No. So, I need to give a proof that I have a part of my secret hash value.
Yeah.
So I can find the integrity between them in the contract.
We don't store secret values in the contract. We only store hash of secret in the contract. That's like identity commitments. And we actually also store identity commitments or like rate commitments. Rate commitments are hash of identity commitment and message limit in the Merkle trees. I don't know how you can, or maybe I don't understand your question.
Is your question, Vishal, how someone can use spamming to reconstruct the secret from 2 messages, or is it a user proving the validity of a message, basically?
Yeah, the second one.
Okay,
maybe you mean to like for registration you need to prove that you know a secret of the pre-image of identity commitment, but you don't have to prove it. You don't need to prove it. You're just like adding identity commitments and you're paying for it. It's like would be bad for you if you don't know secret of this value because you just like stupidly spend some money. And that's it. Maybe this was the question. I don't know. Okay, great.
Yeah, thank you, Vishal, for the question. Why is message ID limited to 16 bits? Nullity, yes.
Because 16 bits is like big value, and we don't need to have, I think, really big. Why do we need to have like 2 to the 16 value? So why do we need to have like, I don't know, million message limit? I mean, we can update epoch basically, but we can make bigger message limit. It's just like, I don't know. We just basically like picked the.
Blockdev is saying that the question is more about is existential. Why is there a message limit to begin with? Message ID limit. Why is there a limit to begin with? Maybe this was the intention. Does it, to generalize the question, is there a, does the type of the variable affect the number of constraints? Rasul, have you come across something like that? Do you know?
Yeah, it affects, but not too much, because like you just making num2 bits operation, and like
right.
Yeah, we do not like limit the value less than 2 to 16, and it's just basically like a general limit, like for everyone. Like you can have like like you can set your user message limit up to this general limit. That's why.
Yeah. Would something break if we removed it right now? If you took that out?
I mean, how can we do that? How can we do it other way? For example, if we allow like users to set like like any like user message limit values, like up to infinity. I mean, how we can then constrain it?
Oh, I think that the question is about message ID. It's not message limit.
I don't understand at all.
Right.
Yeah. So I don't understand at all. What's the question then?
Oh, okay. Yeah, I agree with you. So the message ID, the limit is on the type of the variable, like not the.
Yeah.
Okay.
Yeah.
Okay, yeah. So in the contract,
it's a good question, that why we don't have like why we don't limiting the message limit value like on the contract. It's actually a bug probably in the contract. Good find, but good catch, but in general it's not like a really big bug, because we can still like deprecate this thing on like nodes level. Yeah, but we can add check that we don't have like we like didn't exceed the general limit of 2 to 16 messages. Yeah.
Okay, so I was mistaken. We are in fact talking about limit on number of messages. It's not about type of variable.
Yeah, actually the reason I don't use 16 bits uint 16 because I think it will be like in the storage, it will be padded anyway, so it will still take full storage cell. That's why I used uint 256 for every variable. But yeah, we can make a constraint on the contract also, like to constrain not to have bigger message limits. That's a good catch. Great.
Excellent. That's great. So you can elaborate on that on your report, Nalati.
Yeah.
That's good. Any more questions before we wrap up? We are coming on time. We could take one more. Okay, so I think we can wrap up. Rasul, thank you so much for your time. This was fun. Thank you guys for the great questions.
Thank you. Thanks for having me also.
Yeah, it's our pleasure. This has been fun.
Okay.
Yeah, guys, we'll chat async, and we are all looking forward to our first speaker on Friday. Lev, he's going to take us under the hood of Graph 16 and start digging into the weeds of that. So thank you, everyone, and we'll see you Friday.